So example 2 is looking with sine, cosine, tan. I'll just write sine up at the top. We're looking at the b value. What happens when there's a horizontal stretch or compression? So in A with y equals cos 6x, that 6 is inside of our function. We would call that a horizontal compression. You would multiply each of your x values by 1/6. So off to the side, I've copied and pasted all of our parent graphs. So we know what our cos graph is, this one right at the top. And a cos graph starts at a maximum and has a period of 2 pi. Now what's going to happen, horizontal compression by 1/6, the period is going to get squished. Can you see that happening? And as a result, when we go to graph this, we would normally start by drawing one period here and split it into 4 equal sections. We normally label that period as 2 pi. But since we're multiplying our x values by 1/6, this point right here, that maximum at 2 pi, is now going to be at 2 pi over 6. Because if I multiply 2 pi by 1/6, I would get 2 pi over 6. You could reduce that. You could write pi over 3 if you'd like, but you don't have to. And since I was multiplying by 1/6, I thought that would be easy just to write that way. Now we have to label all of these other ones. And when labeling the other ones, if you figure out what one full period is, which is 2 pi over 6, does it make sense that the middle dash is going to be half of your period? So if this is 2 pi over 6, if I cut that in half, this will be 1 pi over 6. And the first dash is half of this one. So what's half of pi over 6? Pi over 12. And for the third dash, once I figure out this first dash is pi over 12, since these are equally spaced, can you see that you could just count? This is 1 pi over 12, 2 pi over 12. This one would be 3 pi over 12, which you could write as pi over 4 as well. But you could just leave it at that. Now, since we're multiplying our x coordinates by 1/6, our y coordinates do not change, so our maximum and our minimum will still stay at -1. We're drawing a cos graph which starts at a maximum, to the center line, to the minimum, to the center line, to the maximum. Now this question just asked us for the period, and our period is going to be 2 pi over 6 or pi over 3. But we're practicing to graph it as well. For the tan graph, a little bit trickier with the tan graphs. Y equals tan 2/3 x. For your tan graph, the key things for drawing your tan graph are your asymptotes. So we had an asymptote. Oh, first of all, just label here. What is that 2/3 going to be? It's going to be a horizontal stretch. You're going to multiply your x values by 3/2. So normally, we have an asymptote here at pi over 2. What happens if I take pi over 2 and multiply it by 3/2? I'm going to get 3 pi over 4. Negative pi over 2 change my asymptote to negative 3 pi over 4. My next asymptote here, it was at 3 pi over 2. If I multiply that by 3 halves, it will be at 9 pi over 4. My x-intercepts were at 0. My next one was at pi. But if I multiply that by 3 over 2, I'll get 3 pi over 2. And the shape of my tan graph looks very much like an x cubed graph. And my period well, how far is it between negative 3 pi over 4 and 3 pi over 4? Because from one asymptote to the other asymptote is the period. You could add those up. Can you see that you would get 6 pi over 4? If I reduce that, that's 3 pi over 2. We could also figure out our period by thinking, originally, my period of tan is pi. If I stretch it by multiplying x by 3 over 2, that original period of pi would get multiplied by 3 pi over 2, by 3 over 2, and I would get a new period of 3 pi over 2. Finally, the last example, looking at y equals sine of x over 7. You could think of this as x divided by 7 as 1/7 x. And so now the value in front, this is going to be a horizontal stretch. We would multiply our x values by 7. Remember, all of your horizontal stretches and compressions are the reciprocal. And so if normally my period was 2 pi, and I divide it into 4 equal sections, if I'm multiplying it by 7, can you see that that 2 pi would change into 14 pi? And if you labeled each of those sections, I'd label the middle one next, because it's half. What's half of 14 pi? 7 pi. What's half of 7 pi? 3.5 pi, or 7 pi over 2. And now if I know that the first space is 7 pi over 2, I can find the third one by counting. 1 7 pi over 2, 2 7 pi over 2s, 3 7 pi over 2s, 21 pi over 2. I'm multiplying my x values by 7. That means my amplitude is going to stay negative 1 and 1. Where does a sine graph start? Sine graph starts in the middle, going up to a maximum, back to the minimum, down to a minimum, back to the minimum. So we've learned that your A value, vertical stretches and compressions, affect your amplitude. We are now finding out, what does the B value affect on a periodic function? It affects the period. Sometimes with sinusoidal functions, I refer to the period as the period, starting with the letter B, to help you remember that. But at the bottom of your page, example 2, they've written out some formulas. So I'm going to go there. No. example 1, example 2. Here we go. There. At the bottom of page 517, it says the period of a trig function. And so what I'm going to get you is to write out these formulas. Your b value isn't your period. Unlike your a value, where your a value is basically your amplitude, your b value helps you find your period. And since the original period for sine and for cosine is 2 pi, and your b value is horizontal, so you always multiply by the reciprocal, you would multiply your period by 1 over b. So the formula for period of sine and cos is 2 pi divided by your b value. And for tan, since the tan has an original period of pi, your period for tan will always be pi divided by your b value. Later on, we'll sometimes be given the period and you'd have to write the equation. So these second formulas where b is 2 pi over the period and b is pi over the period, those are going to come into play later. But that's just taking this equation and rearranging it to solve for b. You can now do questions 3, C, and D for practice.